This is eHobbyist blog, a log of electronics hobbyist activities aimed at city dwellers who have limited space, limited money, and limited time. My name is Neil. Welcome. During this video, we will take the negative tracking power supply circuit diagram designed earlier and begin constructing a breadboarded prototype. I'm starting with the circuit diagram developed earlier, and one of the first things I do in conjunction with developing a breadboard layout diagram is to color code the circuit diagram. Now, these colors are for critical nodes that will ultimately correspond to the colors of wire jumpers used in the breadboard. So we have the color-coded version of the circuit diagram. And from the circuit diagram, my next step is a breadboard layout. There are some folk who can go directly from circuit diagram to a breadboarded prototype. I'm not one of them. I have to go through this intermediate of drawing a breadboard layout. And the layout indicates the precise placement of components. I try to get the sizes of these components correct. And it also indicates the colors of the jumpers, which in turn corresponds to the colors of the color-coded circuit diagram. And this allows me to go from breadboarded circuit to breadboarded layout to circuit diagram and confirm that what I have indeed constructed on a breadboard is something remotely similar to the circuit diagram I started off with. Often an error in breadboarding is indeed an error in breadboarding that's very difficult to pick up. It's not an error in the circuit as one is likely to imagine. Starting off with the central theme of the breadboarding circuit, the 741 op-amp, and then the associated voltage offset trimmer. Make the connection of the trimmer to pin 5 of the op-amp. That's that green wire, which will eventually get to pin 5, I hope. A series of capacitors. This is C7, C6, and C5, which are going to be used to filter ripple. I now have the feedback trimmer, feedback resistor, and input resistor. That jumper is just taking the input resistor on out to the input strip. And now we've got C9 and C8. C9 and C8 are filtering capacitors going to filter the output of the negative power supply. C9 Now we need our 6-volt load resistor, which is there to drain the output capacitors, make it a little more responsive to adjustment as the levels change. We've got connection to the output of what will be the power transistors. And that's what that violet jumper is. These diodes are there to protect the output from several situations, one of which being connecting it the wrong way to some load that is capable of roasting the power supply. Another situation I'm trying to protect against is reverse polarity that might happen as when you shut the power off. Now I've got the 7805 regulator that is going to serve as the positive power supply for the op-amp. And we have R7 bias resistor for the Zicli pair power transistors, which will boost the current amplification of the 741. What I have here is C3, which is some of the filter capacitors filtering the output of the L7805. C1, C2, C3. Now we're connecting some of the grounds. This ground is going to be connecting the capacitors that are filtering the 7805 to ground. And by that I mean the common of the complementary power supply. Now we have the transistor, and it's going to be used for current limiting. 2905 PNP transistors, the first stage of the Zicli pair. We have the R8 current limiting shunt. And R12, which is going to bias the MJE3055 transistor. There's a lot of fumbling around that goes on with this, and I'm not sure that's being adequately communicated. Things are a lot smoother on this video than they are in reality. I just put the power transistor, MJE3055, into a transistor slot, and now making connections to the 2905. This is the first stage of the power booster for the 741 op amp. Got the base connection to the MJE3055. Now connecting the collector, I think. And the collector is going to that shunt resistor, 0.62, I think it is, which is going to establish a 1 amp maximum for this particular version of the circuit. The printed circuit board that eventually comes out of this, I'm going to make provision for a second 0.62 ohm resistor so that it can be converted to a 2 amp output if warranted. And now the emitter of the MJE3055. This is connected to the input V-. These violet jumpers are the output line of this power amp. And now we're connecting to power. First the positive coming in from the rectifier filter board. Now the common, or ground, this is connected to the center tap, ultimately, of the transformer that feeds the rectifier filter for this set of voltages for the complementary power supply. And there are several ground connections going to the distribution strip. A lot of what I'm leaving out involves stripping wires and shaping wires and cramming wires into appropriate sockets. In this video, I color-coded the negative tracking power supply circuit diagram. I designed a breadboard layout and began constructing the breadboarded prototype. In the next video, we will complete the breadboarding and test the prototype circuit. If you like this video and the idea of the channel, click on the YouTube thumbs up icon. If you want to be notified as to when the next video is available, click on the YouTube subscribe button. If you want to suggest future directions or topics, make corrections to published videos, or voice your opinion on related matters, then leave a YouTube comment. If you want to see supplementary material that cannot be easily presented in video form, such as high-res graphics, files in different formats, lists of references, go to the corresponding website. Until the next time, good day.